Hi, this is Mr. Urrego, and we were verifying that f of x and g of x are inverse functions to each other. We have two functions right now, okay? We need to prove if these two are inverse to each other. That's the main thing. So what do we do to do this? We do the composition of functions, which is basically f of g of x, or g of f of x. In my case, or in either case, if the answer is equal to x, then they are inverse functions. Okay? If my answer is equal to x, then they're inverse functions again. That's the rule. So, composition of functions, we had a video on that. Let's review, let's go over again. I have my two functions. I'm going to do f of g of x. First, you can use either one of them. It doesn't matter. Either one of them will prove you if they're inverse functions or not. So let's use f of g of x. F of g of x. Again, process. Change the inside function. So f of g. G is half of x plus 1. Okay? Then you write your f function. You write your f function, and whatever you have in x, you put a parenthesis. So my f function is 2x minus 2. And where you have an x, this is the place for the x. Instead of the x, I put a parenthesis and I bring down whatever I have in the previous parenthesis. And now it's algebra. Distribute the 2. 2 times half of x is equal to 1x. 2 times 1 equals to 2 and minus 2 on the outside. You notice 2 minus 2, they cancel out, and your final answer is equals to x. Because I got equals to x, that means they're inverse to each other. So f and g of x are inverse functions. Alright, that's how you prove it. Let's do the other process, g of f of x. Let's see if that's going to work out. It should. So I just did f of g. Now I'm going to do g of f of x. Now your g of f of x. Now your g function, your g, so let me 2x minus 2. So f of x, 2x minus 2, and your g function is half of x minus 1 plus 1. Okay, 2x minus 2 and half of x plus 1. Alright, so that's your function, half of x plus 1. Now I'm going to do g of f. Again, replace the inside first. So g is half, you replace the f function. So I'm going to do g of f. Instead of f, I write my 2x minus 2. And then I write my g function. Instead of my g function, I write half of x plus 1. So it's half of x plus 1. Instead of the x, I put a parenthesis. And then I bring down whatever I have in the previous parenthesis, which is 2x minus 2. There's no exponents on the outside, so there's nothing that I can do, that I have to do for the exponents. I just distribute that 1/2. 1/2 of 2x, or half of 2x, is 1x. Half of negative 2 is negative 1, and I have 1 on the outside. Negative 1 plus 1 cancel out, and my answer is x. Therefore, they are inverse functions. Okay? You do your composite functions and you get x, they're inverse functions. Let's do one more, something that doesn't work out. So let's try these two functions and let's see if they're inverse to each other. Again, the rule is, once you do your composition of functions, if you get equals x, then they are inverse to each other. If it's not equal to x, either way you do it, this or this way, it doesn't matter which way you do it. If it's not equal to x, then they are not inverse to each other. I have f of x and g of x. Let's do f of g of x. First step, inside function. So I have f of g of x. Instead of g of x, I write my 3x minus 5, right? That's your g function, 3x minus 5. Now I need to replace my f function, which is the function on the outside. So your f function is 2x plus 4. 2x plus 4. If you notice, whenever I say 2x, I put a parenthesis. 2x, instead of the x, I put a parenthesis. That's the whole idea of a composite functions. Okay? 2x plus 4. Instead of my x, I put a parenthesis. What goes inside my parenthesis? The previous parenthesis, which is 3x minus 5. And after that is just algebra. Okay? Distribute. 2 times 3x is 6x. 2 times negative 5 is negative 10 plus 4. Combine whatever you can. You get 6x minus 6. Is that equal to x? No, it's more than x. Therefore, they are not. Wow. They're not inverse functions. Okay? That's supposed to be functions. So that's how you prove inverse functions. I hope this is clear. Alright. Take care.